Turn on the recording. The recording is on. Welcome into class, everybody. This is Design 330. It's week number 4, and this is what to do this week. And I want to note that Friday the 12th is a holiday, and Monday the 15th is a holiday. Saturday and Sunday are not holidays. You're welcome to work on those days, but I'm not going to be available on Friday or on Monday. And of course, I'm mostly not available unless you're really having issues. I usually don't even recall on Saturday and Sunday. But here's what we're going to do. We're going to, and you'll have plenty of time. Don't worry about this. This is still a preparation week. Believe it or not, we're still preparing. We're going to use your research that you've done so far. Okay. It's what we do this week is supposed to be based on what you've done so far and on your research, and you've done some product design, and we're going to do what's called a design review. Now, a design review is always backed up by solid information because you're really just presenting a lot of options and the support for those options, or what's wrong with those options. And once you get those all together and rattle them around between everybody and in your brain, you can usually come up with a design improvement. So that's what we're going to do. We're going to do a design review. Now, that's going to be really interesting. We're going to do it virtually tomorrow in lab. If you're not available, you will be able to still access our Jamboard that we use and give valuable input. Okay? So, why are we doing this? This goes along. These are, I'm sure you've all read our student learning outcomes, and here's 2 of them. The design review is really 2 of the key ways. Sorry, at 10 a.m. Did I say 9? It's at 10. Regular time. Regular time. So thank you for catching me on that. But our student learning outcomes say you're supposed to do these 2 things. Produce finished documentation specifying the use and applicability of certain mechanical products in an application. That is exactly one of the things that's met by a design review. A design review does this. And of course, we analyze the application in accord with professional workplace practices. So the way this is doing the design review does this, and the way we do the design review does this. So I just want to let you know, these aren't just like la-di-da things. Now, I'll tell you, one of the very first design reviews I ever did, I got out of college and I was working for Tri-Tool, and Lawson Null was my engineering manager. And we did a design review, and he came up after me and he goes, "You were absolutely useless. What was the matter?" And I go, "What?" And he goes, "You didn't input one darn thing. We got absolutely nothing out of you. You're hired to be useful." Oh, man, was that ever brutal. He goes, "Next one, I better see some useful input." Youch. Tried to actually beat me up quite a lot, but I learned tons. And then even ever after that, I understood that my job was to be useful. I needed to give input. Jerry Vanderpool was great. He was my engineering manager at Tri-Tool when Lawson Null went back to Aerojet. He was actually an aeronautical engineer, and Aerojet basically hired him away from us at Tri-Tool after about 10 years at Tri-Tool. And Jerry Vanderpool became our engineering manager. And man, we had design review after design. And those, you needed to give input or you weren't invited back with him too. And then probably where I learned the most about design reviews were Dave Sinclair and Dave Barrowman. Dave Sinclair was the engineering manager at Wemco, and Dave Barrowman was the sales manager. And when we had a design review, it was very, very specific. Um, and I was in on a lot of those. And the purpose of the design review was, the first design review was, can we do this job? Okay, because sales is notorious for selling things that can't be made. So it was, can we do this job? The next design review, can we make money at this job? And the third design review, can we get this job done on time? We had 3 very specific design reviews before we could accept a job. Now, some of them were super easy. It was just like, yeah, it's a duplicate of this other job. We just have to change this, 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 and this. And we could do all 3 design reviews in 5 minutes because it was so simple. Okay. Every single job we did that was not an off-the-shelf product, and that was most of our jobs, was special products. It was a specialty pump company. Had those 3 things. So that's where I learned that design reviews can have a specific purpose. So we're going to pick a few specific purposes and do one design review. Okay? So and this is just what I've learned through my career in engineering and design. So here's just stuff, right? You can go here. I don't know that I've even got anything in here. I do have the playlist. Oh, the playlist. Yeah, it's got a few things in it. Here's a folder that we may put some stuff in. Attend lab on Wednesday. If you can't attend lab, I'd like you to choose a colleague to work with and do a design review with them and add your information to our Jamboard. If you're unable to do that, then at least watch our video and then add information to the Jamboard. Okay, so and that's what this is, a shared document, substantive replies. So that's this last one right here. Okay, and here's our Jamboard. Everybody should be able to read this Jamboard by going to it. So you'll make sure that you can do that. And then here's all the rest of the stuff. Remember to make an appointment with me if you need it. So that's what's coming up this week. This week is, again, preparation for your actual design that we're going to do next week. So it's interesting. We're doing 3 weeks of prep for 1 week of actual design. Wow. Okay. And then the rest of it's all going to be documentation. That is how it works in many working scenarios. All right. So let's take a look and see what we're doing today. Here we are. So we're going to do prep work today. And I've already done a video on this. Has anybody watched this video yet? Anybody had a chance to watch it? I posted it sometime yesterday. Okay. So a few people have. I'm not going to spend a ton of time explaining this. We're actually going to do good. Okay, so a bunch of you have. Thank you. So I don't want to go over how to take notes other than to just show you what I did. We're going to more discuss about how you might go get that information that you're going to need. You're going to need numbers, and you have to sort of think about things and decide what numbers you want to go get. And there's 2 ways to do it. Just have some general background knowledge and go get information that's going to help you show other people and prove things. And some would be to have some concept in your mind already and get numbers that help you figure that out and support it. So maybe in your mind you go, well, I've got some experiences that when things are underwater, they corrode. So I really want to make sure that we've taken care of that. You'll go get corrosion information about the materials that might get used on this. And then you might have some background information that says, I've had problems with plastic parts shrinking and growing at different temperatures. So, by the way, I've had experiences with problems in the field with both of these. And you might get, you might just go grab that information so that you can show, well, in the temperature range we're looking at, this is going to grow some amount. And then you can discuss whether that amount is okay, if it's harmful, or it could even be beneficial. Right? So that's where you have some ideas, I'll call it, of changes or things that are important in your mind, and you go get that information. The other one is you just go, okay, I need to be able to analyze information and get it when somebody brings up an issue. I want that all at my fingertips. And that's sort of what we've done. You should have at your fingertips pipe charts, O-ring charts, coefficient of all of this stuff we've been preparing. You should have it at your fingertips so that you can look something up and plonk a number down that supports a statement that you wish to make. And remember, from what I said at the very beginning, to be part of a design review, you have to be substantive. And just saying, I agree, I disagree, no, I think this, no, I think that, isn't substantive. If you say, I agree because I've looked this up and I see that, then you're being substantive. Or I disagree because when I consider this result happens, and that's worse than what, okay? So that's how a design review is supposed to go. I will fully understand if our design review doesn't quite go that way, because you've never been in a design review like this before. You've probably been in some design critiques, like in design 325 or 320 or 328 or something like that. You've probably been in some design critiques, but maybe not as structured as what you're going to see in this one. Okay? And I'll try to lead us through, and it's a learning experience. I would like you all to participate in some way. I know that's really hard. Sometimes people go, I don't want to say anything because somebody will contradict me. That's perfectly okay to get contradicted. As a matter of fact, when I think about it, if somebody brings up a point and somebody can contradict it, we've just got information, and the person who brought up the point that allowed the other person to bring up another point is actually the hero in the game. Okay? Even if their idea or their point was contradicted, they drove us to a better design. All right? So I look at, that's how I believe a design review is. That's what Lawson Null taught me. That's what Jerry Vanderpool taught me. That's what Dave and Dave taught me. And that's what has worked for me all through my career doing design reviews. Okay? Anybody got a question about or a concern about doing a design review in this way? Like, I don't know, I don't like it. Okay. But I'm going to look forward to hearing something. And you're not even going to have to say anything in this one if you don't want to. I am tomorrow going to ask everybody to unmute themselves and talk when they have something to say. But we're also going to see that on the Jamboard, you're going to put sticky notes up with your comments. And if that's what you would prefer to do, especially many of us, if you're doing this through VMware or something, you don't have a microphone. So if you don't have a microphone, it could be really hard. But we will want you to interact. Okay? Cool. And please, please, please know, every comment that has substantive information is a good, valid, useful comment, even if somebody else has information that contradicts it. Okay? The things that are not that useful is just say, yeah, I agree with that. That doesn't actually help us. It's not a vote. This is this is the last thing I should say is usually a design review is meant to present information to the person or the people that are going to make the decision. Now, in the case of TriTool, when I worked there, it was the engineering manager. They were going to make the decision. And the purpose of a design review was sort of more like the king's counselors. The king would make the decision, but the counselors would all say, their piece. Okay, so we were all counselors to our chief engineer, and our chief engineer wanted as much information as possible. And our chief engineer had a ton of experience. So the experience portion, our chief engineer knew more. That's not always the case. Sometimes you have designers that have more experience in one area or another than the chief engineer, and they may ask for an opinion. Okay, gut check. Is this going to work? Gut check. No. Okay, let's figure out why. That can be how it goes, but none of us are in that position right now. So your job is going to be to present this information. Now, it turns out that next week, you become the chief engineer and get to make the decision. But right now, you're going to be presenting that information to me, the chief engineer. In the case of Wemco, where it was Dave and Dave, engineering manager, sales manager, the way the system was set up is they had to come to an agreement. They both had sort of like veto power on a job. If either of them said no, the job didn't get accepted. Now, you can imagine that had a lot of responsibility. And even though they would go at it and disagree and everything, they both were working for the benefit of the client and the company. And they often disagreed and had real strong, design review differences of opinions. But in the end, we were one of the strongest companies that I've ever seen work for. So don't worry about disagreements, anything like that, but you're going to present the information as if you were presenting it to me, and I was going to make the decision on what this final product was gonna the design requirements were going to be. Turns out that next week you get to be the chief engineer, and it's your design, and you're going to have a week to get that design sort of not done, but designed. And then we're going to do all the documentation. Okay? So here we go. Let's take a look at the Jamboard first, because that's going to be the key to what we've done. So once we're into this, so Michelle, thank you. You've got your name on here. Once you've accessed this, we want your name on here. That's how we're going to know that you have partaken in the design review. Okay? And then there are a number of areas that you're going to be asked to review. Operational functionality. Okay? So operational, and we'll talk about that, right? What is the capacity? So somebody's going to say, okay, if it's a half inch, then we're going to be able to pump blah, blah, blah. And somebody will go, well, yeah, but if my tube is 40 feet long and it's a 3/8 inch diameter tube, that's going to take to clear the water out when I do this. And you're going to need to be able to do those calculations right then and there so that you can give that information. What if we're 40 feet deep? What if we're 10 feet deep? What if we're 20 feet deep? And we have to clear the tube of water that's in there to get to the new water that's 20 feet deep. Well, you have a pipe calculator. 3/8 inch pipe, 40 feet long. How much water is it? Blah, blah, blah. What's the capacity? So you can start adding information. Okay, I think this is going to be too small because it's going to take 15 minutes to pump it all out. Or, hey, no, that'll be better because if we'll make that really big. But then somebody will say, oh, yeah, but if it's really big, our pipe volumes. But we'll talk purely about functionality on this page. Okay, can I grab this? Can I grab this with a remote operated vehicle? Or does my block need to be bigger so that there's some place to grab? There's tons of things to think about, and that's your job today. What questions could we ask and then answer to ensure that this is the most functional product? And this is just something for us to talk about. Okay? Maybe we don't like where this is placed. It adds a problem to the functionality. Maybe we don't like where this is placed. It adds a problem to the functionality. Okay? Maybe we do like it. Maybe we don't. Okay? So functionality, how does it operate? Let's look at a few other things that have to do with functionality. I'm going to open up our thing here. So what does it say about functionality? And you're just going to think, oh, those are material properties, functionality. Okay. Oh, by the way, you should get these material properties well set. Have the information about these. And I think I showed you how to do that. Be ready. This is to get ready. Have your information. Have your information. Have your information. Have your information. So that when we talk tomorrow about functional operation and functionality, you've got some questions to ask. What if? What if? How is that? And what do we talk about? Pump capacity. Driver. How do we make that thing go back and forth if it's underwater 15 or 20 feet? Are we going to send a diver down to push and pull on it? I don't know. So you'll talk about our pump capacity, our piston driver, and then how are we going to make this work with the ROV? Okay, and hopefully, and these are questions you're going to ask and have information that you can apply. Okay, so that's one. Our next one is number of parts and ease of manufacture. So how could you minimize the number of parts? How could you maximize the ease of manufacturing? So you're going to want to prepare with some questions. Okay, and what you're going to do is you're going to take snips of this Jamboard and put it in here. That's going to be your documentation. Snips of the Jamboard become your documentation down here. But you're going to have to identify what your input was. Okay, so number of parts. How could I potentially reduce the number of parts? Could I do that? Or how could I make this easier to manufacture? Okay, and they're just questions you're going to, well, what if I made this part and this part all one piece? What if I made this part go directly into here? Okay, what if I made all of this one piece? What if I put all the little parts of that check assembly inside of here and didn't even buy a check assembly? So, number of parts and ease of manufacture. And we'll discuss those things. Ease of use and maintenance. How can I make this as easy to use as possible? Because remember, this is going to be underwater. Okay? Potentially, you don't want all of this underwater. Maybe you only want that part underwater. And maintenance. Well, these things screw together. Maybe they should snap together. Maybe they shouldn't be a screwed piece that goes together. Maybe I can eliminate some corrosion problems. Whatever you come up with here, ease of use, maybe this is not the way to make this thing draw water in. Maybe there's a better way than this piston. Maybe you've got a better thing to do. How do we make this ease of use? How do we make this piston work? That's part of functionality too. Maybe an O-ring groove isn't the thing to do there. Maybe I want one of those diaphragm things. Maybe a diaphragm would be way easier to work than this O-ring. And that could be on our next one too. Where was ease of manufacture? Okay, this piston thing could cause us problems manufacturing wise. Maybe we want a diaphragm instead of an O-ring. So these are all questions that I would ask in my mind. And if you've got one question that you could ask on each of these and be prepped, that would be good. More questions, the better. How about maintenance? Can I get this thing apart? What if this cracks? What if this fouls? What if my O-ring gets stuck? What if this goops up with seaweed? What if a fish bites this thing and eats part of it? They got big old sturgeon and stuff down there. Who knows? What if it breaks right here and that goes swimming down the river and all I've got is that left? Okay. What if that's durability? What about this joint, this joint, this joint? Will they work down there? Do I need a cage around it? Product life. What am I going to do with this when it breaks? Do I just throw it away? Do I reuse parts? Do I have to sterilize them? Are they what if I've used something that can't be made? Okay? So these are all things that we would be. So now so Wasan, what you would need to do here, so here's an example Wasan put down. I would prefer it to be longer. Okay, so what you would need to do here is show why and how and what that would do for you. Okay, so there would need to be some because. And we'll really do this mostly tomorrow. What I'd like you to do is prepping all this, but that's exactly how we're going to do it. And then if we find out something else we need to do, we can come in and either just ask questions and answer questions, or we can make a duplicate of one of these and work with it. Okay? So that's how this is going to work. That's what our preparation is going to be. So your job right now is to make sure that you have data. Like one thing somebody might be looking at is, well, if I make that pump capacity bigger and I still have these tiny little check valves, maybe I've got a problem. Can I find bigger check valves? How about a 1/2-inch check valve? Is that the best type of check valve? Are there other types of check valves that I can use? Okay, so your prep work between now and tomorrow is key. Be able to answer as many questions as you've got. Lots of time involved between now and tomorrow, if you've got that time. If you don't, then you'll get onto the Jamboard sometime and start putting your information down. The goal is that everybody, so yes, and Wasan, go ahead and put your tag on this one too. So you just go to sticky note and put your name on it. And you can make yours a specific color if you want and things like that. Okay? And if you'll notice when Wasan put the comment in, she put her name on it. So you can put your name, your initials, things like that. You can color code them, but we don't have that many colors. We don't have as many colors as we've got people. Okay? But that's how our design is going to work. Now, normally there's a person in the design review that's taking notes, and literally from my very first one, we had a flip chart with paper and little yellow sticky notes that somebody would be writing, stick it up, so that we could just write really quick. And other people were just writing on their sticky notes, and they'd hand it to the sticky note person. Okay, which was sometimes an administrative assistant, sometimes it was a junior engineer, sometimes it was our chief engineer because they wanted to see everything as they were putting it up. But the old sticky note on the wall or next to a drawing is just key to getting these done. Now, if you'd like to, you'll be able to. Let's talk about this functionality thing, right? Maybe you'll go like this, and you'll say, okay, that thing is what? That's our up to 40 feet of tube to the surface needs to be pumped between locations. So maybe and that's not an opinion, that's a statement. And then somebody can come through and go, no, we'll never go 40 feet deep. We'll only go 30 feet deep. Okay? But that is information. And then somebody else could come in and say, that is 1 gallon in a 3/8 tube. And so now we're starting to get, okay, so I have to be able to pump a gallon out before I get a good sample, right? Because if this tube is all full of a sample, and then I move my ROV and start taking a new sample, I got new water, I have to get to the point where new water travels all the way up. And then somebody else will go, yeah, in a 1-inch tube, that's. So people can start adding information so that you can then start talking about capacity. Okay, well, when we get to capacity, that's okay, I need a gallon. How long do I want to sit there to evacuate the line? 2 minutes. Okay. Da-da-da-da. See how we can do a real design review. And there is no right, there is no wrong. There's discussion, there's gathering information, there's learning about our product. So do you see how that might work? And I'm not sure I can get rid of that thing. I might have to. There. Okay. So we'll be able to do things. And when we're working and discussing things, we can use this little tool down here. If you feel like it, you can add text. If you want to circle something, you'll be able to do that. And I think you can change the color. Huh. Looks like it's always black. Huh. Send it to backward or I don't know. Yeah. So I'm not sure that circle thing is going to work great, but we'll see. There it is. Yeah.
There's a way to change the color. I think it's if you it's on the top.
I know I can change the color for my pens. I was trying to
If you
change
click
it
the circle and then there's like a color change on the like in the tab up there on the top.
up, up.
You have to click the circle first. And then the pen up there in the top
Oh,
corner.
then you have to change it.
No. More higher. Like below the title piston pump design thingy review.
Oh, it's up
Yeah,
here
but you have to
somewhere?
click on the circle first.
I don't see a circle. Okay,
No,
so
no, click on the circle.
oh,
Yeah, and
there it
then
is. Oh
yeah.
my gosh. How, I love it. Here's one interface here, and in the same program, a totally different interface. Oh well. Cool. Thank you. Got it.
Yeah.
There we go. See, always rely on your students to tell you how to run a program. It works better that way. Okay. So that's how we're going to do it. Your job for preparation for tomorrow is make sure that you can have on hand information about materials, information about costs, and now we're going to talk a little bit about machining basics, but you're not going to have enough information at this point to really do anything with it. But I'm going to let you see something. So it takes a long time to make a part if you just have to make it. Now, in general, the faster you make something, the more expensive the equipment. So if you want to make something out of a casting, you have to make patterns or injection molding equipment and do all sorts of stuff to get that part made fairly quickly. And that means that you have to make a lot of them. To make a
Hey,
few
Rich,
things, yeah.
I have a quick question. So I was thinking if we made the mechanism out of a plastic, so would that mean our machining basics would be talking about the different ways to machine the plastic, for example, injection molding,
Okay,
those
so
kind of processes,
okay,
or
so
how are we
so
doing it?
machining refers to actually removing materials. So you're using a cutter of some sort or a grinder when you're talking about machining, a mill or a lathe or a grinder, and you can
Oh,
do
okay.
that to plastic. Okay? And different plastics machine different ways, just like different metals machine different ways and different ceramics machine different ways. Injection molding plastics is a whole nother thing that's not considered machining. It's called injection molding. And then, and the casting is another thing. So we're going to talk about machining basics because at this
Okay.
point we have to know that's going to be part of the cost, and the cost has to do with how many of these do you think you're going to make. So if you've been doing some background research about environmental water quality and things, you might find that there's a big need or you might find that there's a small need. And your job is to factor that in. There's a huge need. We're going to design this for this. I know we'll spend money on prototypes, blah blah blah, but I'm going to make 10,000 of these. Well, now your injection molding will cost you $30,000, so it'll be 3 parts, $3 per each part that you make. So you'll be able to do some of that thinking. But here's what I want you to do. I want you to come over to here and here's a little video tutorial on how to use your milling machine simulator. And here's the simulator. So I'm going to go through this just really quickly. And I want you just to kind of like get an idea of how long it takes somebody just to square up a block. Okay. And so you can pretend that this is a block of material. Who knows what that material is? Now we've got our settings for working on like a piece of steel. Other things will be able to change this number eventually depending on what material we put on here. But just pretend that this is a block. And if I measure that block, currently it's 3.937. That happens to be 100 millimeters by 100 millimeters. Tells me right there. And so this is my milling cutter. It's a very fast moving cylinder with sharp blades on it. Okay. And when I move it, it cuts things. Now you'll notice that green dot. That green dot is where I'm counting my X and Y coordinates from. So as I move X, my X number is getting bigger. As I move Y, it's getting bigger because I'm moving in the plus direction. If I move down to the point where I'm underneath the dot, it's going minus. So these are my controls. This is my cutter. I can fast travel, which is sort of like I've moved it up and I'm just getting past something. I'm not cutting. Okay, and I can really fast travel fast, or I can fast travel slow. And this is just like what we would call a Bridgeport mill. Okay, now up here is where you get to type for yourself what dimension you want on the block at the end. Let's say I want 3.25 and 2. Well, I got a lot of material to take away. So maybe I want a big cutter that can cut a lot at once. Okay? Maybe that's what I want. So there's lots of stuff. This is just like running a mill. Okay, so now I'm going to make a cut. Oops, I'm running too slow. I'll still run fast. And I'm cutting into it. Now maybe I'll cut up. Oh, look at that. Isn't that cool? It actually does. It does make the cut. And so now I'm cutting with a big piece. And I just want you to get an idea of what it takes. Isn't this the coolest thing ever? I played with this for like an hour and a half last night. And this speed is about right for a milling, a mill, a Bridgeport mill. You can go beefier and really move faster, cutting a fairly hard alloy steel. Okay? If you're cutting something else, you can move faster, but we've got it set for this. Okay, so here we go. I'm almost done, almost done, almost. So your job is to just cut something, make sure that you can move the controls, and put a screenshot in your portfolio. Next week, you're going to actually have to make parts of a certain size. There we go. I've made it all through. And now let's see. I'm going to measure it. Okay. So now I'm measuring 3.4 from here to here, 3.49, and 3.9 from here to here. So now I have to figure out how much do I have to move this over to make my next cut to get it right at what I want, 3.25. So I have to figure out, how do I move it from this? How do I move my tool over to get right to 3.25? Okay? Well, the easiest way is to just subtract 3.491 minus 3.25. I have to move it over in the plus x direction, 0.241. Man, let me zero it. And I want to move over 0.241. I'm going to go kind of slow. Because if I go too far, I've blown it. I'm going to slow it down even more. Oh, I'm so close. 241. Okay. Now I can continue with my cut. And I should be cutting it right to 3.25 if I did it right. And we'll see in just a minute. So that's how that's the process of cutting material to be the right size. And this is obviously the most simple thing we can do. We're just doing what's called squaring up a block, getting it to the right size. Okay, and there's lots that you can learn about this. After you're able to do this, we can have lots of discussions about, choosing the right material size to start with, doing skim cuts, if you want a climb cut or a draw cut or a run cut, what size cutter to use to get a certain surface finish, what speeds to use. There's tons of stuff, but until you can get your size right, it doesn't make sense to try anything else. Okay, so let's see if I just made my part 3.25. I'm going to turn the power off. I'm not. Okay, I'm off by 2.5 thousandths of an inch. And that's just my machine. My machine won't do any better. Okay, just the way I've got, where I am and what I've got and my measurements and the size of my cutter. That's still not too bad. 2.5 thousandths. Most machine tools right now will cut within 1/1000th. Okay, but you can see my tool cutter isn't perfectly round. Right? But I got a pretty good part. So I can do a screen capture, click, and there it is. I can put that in my design review basics. There we go. That's all I'm looking for. Right there. That's how you do your machining basics. Probably take you 15 or 20 minutes unless you go, I want to learn how to use a mill. I want to do this. And this is the first part. Start moving X and Y, finding out what happens. Now, two things to note. This is in millimeters, so if you're calculating radii and diameter, you have to recalculate. And that happens. Often, machine tools, you only have a metric set of tool heads, of cutters. Okay? Notice that the travel is in millimeters. That's happened to me over and over and over again. The most common way to retrofit one of the old machines that you crank by hand with a motorized cutter is to retrofit it with a Yamamoto or a Yakuzuki or, one of the Japanese ones, and they're all in metric. That's all they got. So, and who cares though? That's just your travel speed, and that's just your tool diameter. These are all consistent. Your tool center here and here. Last measured part dimensions and what you're trying to get to. Okay, so just know you're working with a few different things. Okay, so I've got about 10 minutes, and now I'm open for questions on anything, on how to prep, what we're going to do tomorrow, what to do if you can't do this tomorrow, how to use our cool milling machine. Anybody have any questions?
I will have a question. I just need to prepare for it. 1 second.
Okay. Okay. Do you need me to stop sharing?
I think it's fine. I just want to look at the slideshow to
Okay.
know what I was talking about. Let's see here. Okay, piston pump. Okay, so I just want to clarify. I guess I get confused every week somehow about what we're actually doing for each section. I get the content, but the actual like what visual display. So I want to clarify for let's see here, content of 4.2.1 through 5. So operation, functionality, number of parts.
Okay, so that is
that?
once we've done our design review. So let's look at ease of maintenance.
Yeah, maybe actually, if I don't know if there's time
So
in
watch.
2 minutes just to go through the slideshow again. I don't know why.
Yeah. So you're just going to take a snip of this when it's done, and you're going to put it in yours. Okay?
And that's after
So
we've already put the comments on it.
uh-huh. So now
Okay.
I'll duplicate the slide. So you're going to have this, and then you're going to make a call out. Okay, where did we talk about pump setup and startup? Where did we talk about spare parts interchange? So you'll come back down here and you'll go, okay, I know where that was. This is, that's my pump startup. And I know where another thing was. Right? And so you'll circle and highlight the notes that talk about these different things, and then you'll highlight which ones are yours. Okay?
Okay.
So let's say these ones. Okay. That one's just a scribble, sorry. Let me do it this way instead. I'll use these ones. I just happen to like doing shapes. Let's say that there was something right there, and you turn it transparent, but you make a certain color on it, right? And you put, this is setup. So that's where all the setup things, you go, okay, that's talking about setup right there. And you can look and see what it says, right? So that's one way you can go about it. Another way is you can just go like that and say, okay, here's important things about setup, blah, 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 blah. And you can just draw little arrows to them.
So for this evening, is this where we would kind of conceptualize questions?
Yep.
So I'd think about like how can I make, and so I'd write notes about like possible ways to make it easier, and we'd just document it like notes
or even image. Comment. Yeah, yes. So you start questioning things. Okay. What might be hard, what might be easy, what might be difficult. Right? And so you can, and that's up in your prep area. So up here, you're going to gather resources, right? And here, you're going to start writing questions. And you could even, if you want to, start going, how much do we need? You can, this just becomes a tool for you. Now, what I showed you how to do in the prep thing, right, is to put notes out here. What about when we are under water? How do we clear the line for a new sample? Okay, so you can put notes over here that are just going to help. This is what I do actually. Okay, I got to get my questions ready for pump capacity. How do we do that? Right? How How do we think about future pump capacity? So we might need what tests are going to be run. How much water do we need? Well, you should be able to answer that because you've got a whole bunch of background on what tests are run. You studied that a little bit. So now you'll go back, oh, where am I going to find that? And you could even right here say, check in week 2, section blah, 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 blah. So this is how you prepare. Maybe it'll come up, maybe it won't. Right? But if we're starting to ask, okay, what are going to be run? Oh, yeah, where do I have to? Okay. Find out how much water is needed for some test. So you may or may not be able to prepare everything here by tomorrow.
Mm-hmm.
But if everybody gets 1 or 2 or 3, you're okay. And then you can spend the rest of the week kind of backfilling and seeing how it would go. This would really be, if I were doing this really for a design review, I, with experience, would probably spend 2 or 3 hours. So you, without experience, might spend 8 to 12 hours. Well, you don't have 8 to 12 hours. You have a couple of hours, right? So I totally understand that you're going to just do a couple of these to get the process down, and hopefully enough people have some stuff, but you're for sure going to want to know where to go. And if I ask a question, I wonder,
Okay, so
how
it's
much
more
water?
recommending.
Yeah. If I ask the question as the chief engineer, how much water is it going to take if I use a 3/8 tube? Somebody better pop that out for me within 30 or 40 seconds because you've got the calculator handy. Right? And you never want the chief engineer to beat you to the punch. You always want to be faster than the chief engineer. That's just the way it is. They should be the rickety old dude. Okay. Okay.
Okay, so
So
that helps. It's more writing down the or investigative questions about
Yep.
these subject areas to prepare for tomorrow's
Yep.
discussion.
And get them written down wherever it seems like it's reasonable. Okay, I'll leave this one on here if anybody wants to get to it and they can go look. Okay, but this is the example that I show. Use these areas to help you prepare and find stuff and work on it. It's so great to have these. And if you want to make this, make everything doing with pump capacity a certain color because it's easier for you, then do it, right? Make and the ones for the piston driver, make that a different color. So Wasan says, how many comments should we make in the design review? What I've asked for is in the design review, I'd like you to be able to input one question on each slide. Now, if there's 8 of you in there all doing it, somebody might beat you to the punch, and that might be hard. But if you show that you were prepared with your work, we can do that. Okay. And so normally in a working world you'd have time, right? Now I'm just teaching it to you now. You're going to have a day to get it done. You'll do a couple of hours worth of work, hopefully, and then we'll get it. Okay? And you'll be able to prepare a lot better after you've been through it, which is kind of hard, but that's okay. It's a learning process, and you can't learn how to prep until you've been through a couple too. All
Yeah,
right?
this is great though. What do they call it? A learning curve, right?
Yep. Yes, they do. Okay. And I've got a production meeting to get to, lo and behold. So I'm going to go ahead and log off of this, go on to my meeting planner appointment schedule if you need to get a hold of me and ask some questions this afternoon. Feel free to get on there and I'll help you go through some of these, okay? All right, folks, good stuff. I'm going to log off. Bye.